So, first of all, disregard the chapter. This chapter 1.1 does not coincide with 1.1 in your orange book, but it definitely deals with chapter 1, variables and expressions. So one of the first things we want to look at is, first of all, the vocabulary. So algebraic expression, what does that mean? Well, algebraic means that it's going to deal with numbers and variables. An expression does not have an equal sign. Okay, so that's really important. Variables are letters, A, M, any letter in the alphabet. Terms are single. You can have a single term, which is called a monomial. You can have two terms, which is called a binomial. Three terms, trinomial. And then anything that has four or more is called a polynomial. And a term can be a number itself, or it can be a variable, or it can be a number and a variable. So you can have 3x. Factors are numbers that are divisible, integers that are divisible into them. Product means multiplication. We're going to use that sign. We're not going to use the x sign to show product. Power is an exponent, so power and exponent sort of end. We can even throw in base there. So when we have y to the fourth, we have the power. Well, this is the exponent, this is the power, and this is the base. So we'll go over it a little bit more when we go through this. But just to give you a quick brush up on what vocabulary we will be learning and using in this section. So the first thing we need to do is write verbal expressions. So we're going to translate a verbal expression into an algebraic expression, or we're going to take an algebraic expression and we're going to write it down as a written expression. An algebraic expression consists of sums and or products of numbers and variables. Well, you say, hey, what about subtraction or division? Well, one of the things we need to know is that addition and subtraction, so if we have 3 plus 6, or if we have 2 minus 7, 2 minus 7 can always be written as an addition. So subtraction is really, there's no such thing as subtraction. We can get really technical, but technically there's no such thing as subtraction. It's always addition. And when we have multiplication and division, you can have 2 times 4, and then you can have 2, let's not use 2, let's have 3 divided by 5. Well, 3 divided by 5 is 3 times 1/5. We convert the division to multiplication by taking the reciprocal. I don't know if you remember that when you were dealing with dividing of fractions. You always took the reciprocal of that right side. So technically, there's no such thing as division. Every division is multiplication. So when they write that statement in the algebraic consists of sums and or products of numbers and variables, that's why. So you could also say consists of sums, differences, products, and quotients. In the algebraic expression 0.10d, the letter d is called a variable. That is an unknown value at the moment. It doesn't have a value. In algebra, variables are symbols used to represent unspecified numbers or values. So, much like what I just said, any letter may be used as a variable. So you'll see D, X, Z, P and Q, C, D, M, N. So those are all variables. These are all algebraic expressions. Why are all these algebraic expressions? Because there's no equal sign. Yes, good. So we know that those are expressions. This has one term. It's a monomial. This has two terms because you have addition and subtraction separate terms. This is also a binomial. It has two terms. This is a monomial. This is only one term because this can be written as PQ and there's no addition subtraction between them. This is also a monomial. That is one term because it can be written like this and there's no addition and subtraction. So whenever we see addition and subtraction, that separates terms. So this would be considered a binomial, two terms. Very good. So that's always good. A term of an expression may be a number, a variable, or a product or quotient of numbers and variables. For example, 0.10d, 2x, and 4 are terms. Those are each terms. A term that contains x or other letters is sometimes referred to as a variable term. Sure. A term that does not have a variable is a constant. So if there's no variable with it, it would be considered a constant. That that term isn't going to change. That's not good. Does that sometimes? I don't know why. In a multiplication expression meaning you won't see an equal sign, the quantities being multiplied are factors. The result is the product. So x and y are factors of each other, and they're factors of xy, meaning x goes into xy, y times. So we can write multiplication like xy. We can write it x times y with a dot. We can use it with parentheses on the second one. We can use it with parentheses on the left one, and then we can use parentheses for both. So I love this. You will not see this in my class. We will not use this as multiplication. We don't use x as to show product. Okay, but all of these are perfect. I love these explanations. That all means multiplication of those two factors. An expression like x to the n is called a power. The word power can also refer to the exponent. The exponent indicates the number of times the base is used as a factor. In an expression of the form x to the n, the base is x. The expression x to the n is read x to the nth power. When no exponent is shown, it is understood to be 1. For example, a is equal to a to the first. So whenever we see just a variable, we know that there's an invisible 1 here. All right? Otherwise, we'll see it. You'll see x to the second. You'll see y to the -3. You'll see z to the 1/2. What? Yes, fractions as exponents. You will see, that's pretty much it. You might even see y to the 0.3. You'll see decimals. So again, when we have this, so when we see x to the second, that equals x times x. This is the base. That's what we're multiplying times itself. And then the exponent or the power tells us how many times we're going to multiply it. So we're multiplying x times itself 2 times. So when we have z to the 4th, my base is z. So, and I'm going to multiply that base times itself 4 times. Here's the tricky one. What if I have 1/4 to the 3rd? What's that going to be? What's the base of that exponent? Here's the exponent. What's the base? 1/4, good. So we're going to have 1/4 times 1/4 times 1/4, 3 times. When we have -8 to the second, what's the base of the exponent? -8, good. -8 times -8. Why did we include the negative? Well, we see the parentheses. We see what I call Chewbacca arms. Yep, that was my Chewbacca noise. So notice the parentheses tell me to include the negative. Here's a tricky one. Giving you tricky ones already. Can I do that? Oh yes, there you go. What if we have x to the third y? Let's do xy to the third. I like that better. So what is the exponent of this base? There's a 1 there. What is the base of this exponent? It's just y. So if we wrote this out, that would be x times y times y times y. That 3 does not affect the x because there are no Chewbacca arms. So the counterexample of that would be something like this. mn to the second to the third. So we have mn to the second times mn to the second times mn to the second. Notice what the base of this exponent, there's the exponent, and the base is going to be this. So we have that base 3 times. Let's not worry about what that simplifies to. I just want you to understand exponents, bases, and stuff like that. We will get into the specifics of what that simplifies to down the road. But right at this moment, we want to learn A, first of all, how do you read it? So when we see that, we have 3 times x to the 4th power. When we have this, we have 5 times z to the 4th power plus 16. 5 times z to the 4th plus 16. All right, now here's your try. So what I'd like you to do is I want you to try 1A and 1B. I'd like you to pause the video right now, and then I would like you to write down what you think you would write this down in a written statement, how you would read this. If you were reading this problem to me, how would you read it out loud to me and then write that down on a piece of paper? When you're ready, unpause it, and then we'll go through the answer. So 1A, here's a tricky thing. Some of you would say some of you would say 16 times u to the second minus 3. I'm okay with that. That's not a bad one. I'll take that. But the more correct one, because we don't use minus as much, we do, but this is going to be 3 less than 16 times the square of u, or you can say u to the 2nd power. There's a lot of different answers we could have for this one. Typically when we have subtraction, we use the term less than. So less than, 3 less than, so this less than goes to the 3, that negative gets written there, and then you have 16 times the square of u, or 16 times u to the 2nd power. So I'm okay if you wrote 16 times u to the 2nd power minus 3. That's acceptable also. Let's look at B, 1b. So you can say 1/2 times a plus 6/7 times b. I'm okay with that. You could also say half of A plus 6 times B divided by 7. I'm okay with that. And if you use the term more than, then you would say 6/7 times B more than 1/2 A. So we see that whenever we do this less than or more than, it's whatever comes second goes first. That's kind of confusing. So don't be afraid to say plus or minus. I'm okay with that. Those are good terms. All right, so addition, more than. So what words can we use to represent addition? Well, we can use more than, we can use the word sum, plus, increased by, added to. Subtraction, we use less than, subtracted from, difference, decreased by, minus. Multiplication, the product of, multiplied by, times. And you can use of. That's a unique one. You'll see that when we do some percentages. 60% of 10, right? So we would do, that would be multiplication. And then division, typically we see quotient of or divided by. So now, when we see this written algebraic expression, now let's translate it into a verbal, into an algebraic. So we have a verbal expression, let's change it into an algebraic. A number t more than 6. So I'm going to take this one. I like this one best. You have to be careful with this. A number t more than 6. So we have 6, and then we're going to, that more than goes to the number t. I will be lenient in the beginning about allowing that, but this is the correct one. High school answer is going to be 6 plus t. 10 less than the product of 7 and f. So notice that I will not allow this. That is a wrong answer. 10 less than the product of 7 and f. This 10 less than. So you're taking 10 from. So that's why the 10 gets the negative. You have to have the negative sign attached to the 10. So 10 less than the product of 7 and f. So you have 7 and f, the product meaning multiplication, and then you're going to do 10 less than that. So the only way that that is represented is 7f minus 10. That will be a tricky one. Hopefully you dealt with that in 7th grade. Number C, 2/3 of the volume V. So 2/3 of, remember of means multiplication, the volume V, so we're using volume, and so they give you a variable that you're going to use for volume. So you can have 2/3 V, or notice this one. They will accept this also. And the reasoning behind that is, well, if you have 2/3 times V, what's V as a fraction? What's V as a fraction? V over 1. Good. So that's why 2 times V is 2V, 3 times 1 is 3. That's why these are the same. So that's why 2/3 V is equivalent to 2V over 3. 2 is in the numerator, 3 is in the denominator, V is in the numerator. So if I have this, let's do x to the third. Where is this? This is in the numerator. This base is in the numerator because we know that it's over 1. So that's why we know it's in the numerator. All right, now let's try a couple. So you try these again, pause the video, take these two written expressions and write them as algebraic expressions. When you're ready, unpause the video. So the product of P and 6, we know that the product means multiplication. So we're going to multiply these two factors, whole p and 6. And whenever we write variables and it has a coefficient, 6 would be considered the coefficient. We always put the numbers in front. We would never write P6. That's not going to be accepted. All right, so the product of P and 6 would be 6P. 1/3 of the area A, so we can have 1/3 of, meaning multiplication again, product. So you can have 1/3 times A, or we can have A over 3. Because remember, 1/3, what's A as a fraction? A over 1. What's 1 times A? A. And what's 3 times 1? 3. So that's the reasoning behind that. Real world careers. So sports marketing. Sports marketers promote and manage athletes, teams, facilities, and sports-related businesses and organizations. A minimum of a bachelor's degree in sports management or business administration is preferred. Yeah, so sports marketing is very, very cool. You have agents, you have managers, you have general managers, and then you've got just you've got agencies like CAA, and lots of stuff. So a minimum of a bachelor's degree in sports management, or you can get a MBA, which is called a Master's of Business Administration. UCLA and USC have two of the best MBA programs in the world. You would be lucky to get your MBA from either of those schools. The Marshall School of Business, I think, is USC's, and Anderson School is UCLA. I could be wrong, but I'm almost certain that's correct. Variables can represent quantities that are known and quantities that are unknown. They are also used in formulas, expressions, and equations. So, speaking of sports marketing, Mr. Martinez orders 250 keychains printed with his athletic team's logo and 500 pencils printed with its web address. Write an algebraic expression that represents the cost of the order. So we got 250 keychains and 500 pencils. Well, I don't know how much the keychains cost, so I'm going to give it a variable. And typically we use one of the letters in the word. So we have 250 of these keychains, and we would multiply it by however much it is. So since we don't know how much each keychain is, we would represent it with K. And then we would also add it to the cost of the 500 pencils. So you have 500 times P. Notice that in this expression, we don't write the multiplication sign because that is the simplified. We don't want to have dots in between our so if we have X times Y times Z, we can write XYZ. We understand that what's going on in between X, Y, and Z is multiplication. When we have 3P, we understand that it's 3 times P, that there's multiplication going on between the 3 and the P. So even though I wrote this with it, this is the correct way of writing that expression. And that would give us the value or the total cost of how much 250 keychains and 500 pencils cost. Let's try one. You do this word problem, pause it. When you're ready, unpause. So the coffee shop, Katie bakes 40 pastries and makes coffee for 200 people. Write an algebraic expression to represent the costs of this situation. So she has 200 people and she has 40 pastries. She makes coffee for 200 people and she bakes 40 pastries. So 40 times P. P would be the cost of the pastries, each pastry, each X40, right, represent the cost. Oh, this is bad. This is not the number. This is the cost of pastries sold and the cost of coffee, cost of a pastry. And this is the cost of a coffee. See? Remember how I told you that everybody's going to make mistakes? Even Mr. Mac. So I made a mistake. I made a boo-boo right there. So P is the cost of a pastry. So if I sell 40 pastries, it's going to be 40 times P. P represents the cost of one of those pastries. And if I sell 40 of them, I'm going to multiply that single cost by 40. And then if there are 200 people for the coffee, then I'm going to do 200 times C. Notice I use C for coffee, P for pastries. So when I look back at that expression, I know what each variable represents. At least it gives me a little bit of a reminder. Now, here's what we're going to do at this point. So preparing for the assessment. This is not part of your homework, but this is going to be a good opportunity for you to test your knowledge a little bit. Some of the stuff will be familiar, some of it won't. So I talked about enrichment for students who are looking to get a little bit of rigor in your daily practice. So you may have thought, hey, expressions of variables, I knew that. I remember doing that in 5th grade or 6th grade. And I thought it was easy in 7th grade, and now we're redoing it again in 8th grade. So these little green preparing for assessments, I'm going to include at the end of each lesson. And for the students who want a little bit of a challenge, please take a moment and do these problems. You will have 43, 44, 45, and 46, 47, 48, and 49. Now you don't have to do all of them. You can do a couple. You can look and go, ooh, that one looks challenging. I'm going to try that one. Or you can do none of them. If you're like, this makes my eyes spin. I'm okay with either one you do. Now you don't have to look at the variable or in the video. This will also be included in the notes. So the notes that I print out and include in the assignment will also have the, in case you don't have to go up and down and scroll. And then I include the answers. So once you're done, you can check your answers with the answers that I provide. Here are homework problems that you can also, additional problems. Now these are problems that should be familiar, and these are the questions that we just went over. Similar questions. Write a verbal expression, write an algebraic expression, and then convert these into verbal expressions. So these are examples that you will have and check your understanding. So you should be able to do problems 1 through 10. That will be a good measure whether you know what you're doing. Here are more advanced problems if you want to continue to challenge yourself. Hot problems, higher order thinking skills. These are good ones. And again, please feel free to tackle these problems. You will notice that I include the answers to all of these problems. This is not your homework though. Your homework is going to be a separate worksheet that I will include as an attachment. And then you will grade them and you will enter it. So this is not your homework. This is an opportunity for enrichment. If you want to give yourself a little bit of some extra practice, by all means, tackle these problems. If you are going back and you are trying to prepare for a quiz or an assessment, you can come back to this section and try a couple problems and the answers will be provided for you. Okay? So after this point, Now you're going to do the worksheet, and that will be a separate item on the homework on Google Classroom. So you will see that the homework assignment will be from the practice worksheet.